Audio Jungle.
IC is the abbreviation of integrated circuit, which is what we usually call integrated circuit. So the essence of IC is circuit. The difference lies in the word integration. What circuit is will be introduced later. When it comes to chips, the first thing that comes to your mind may be like this. Of course, this is indeed a typical chip. But what we see is actually the appearance of the chip after packaging. The real chip is actually inside the package. It is connected through the internal LEDs and the pins of the package. The chip package protects the chip. So what is inside the chip? As mentioned earlier, the essence of the chip is the circuit. So the inside of the chip is, of course, some components that make up the circuit, such as resistors, capacitors, inductors, plus some active devices, such as triode MOS tubes. At this point, some people may have questions. I have seen the resistors and capacitors you mentioned, but the resistors are larger than the chips. How do resistors go in? In fact, they are discrete components. The circuit composed of discrete components is called a discrete component circuit. In contrast, it is an integrated circuit. The reason why integrated circuits can be made small is due to the semiconductor process used to manufacture integrated circuits. There may be speculation. Some people may speculate that the semiconductor process is not to make discrete devices small and then shoestringing them into the package mentioned earlier. Not completely correct. Next, let's talk about the implementation of integrated circuits. The circuit on the left is composed of resistors R1 and R2. The two resistors are connected in series between the power supply VDD and the ground. Then the output voltage of the entire circuit is R2, R1 plus R2, times VDD. This seemingly simple circuit actually has a problem. I can't turn it off. To solve this problem, we can connect a switch in series. Control the circuit by controlling the switch. Next, let's explain how to make a simple circuit into an integrated circuit. Start with the switch. Switch is usually implemented by MOS tube. In integrated circuits, the switch consists of three terminals: gate terminal, south terminal and drain terminal. South and drain are the two terminals of the switch. We can control the on and off of the switch by controlling the voltage at the gate terminal. What does the MOS tube in the integrated circuit look like? Most integrated circuits at this stage are made on silicon. Depending on the doping, silicon can be made into N-type and P-type. N-type silicon conducts electricity through electrons. P-type silicon conducts electricity through holes. The MOS tube on silicon looks like this. Two N-type silicon regions are made on the base of P-type silicon. These two N-type regions are the south level and drain level of the MOS tube. Then a layer of silicon dioxide is made above the area between south and drain. A layer of conductor is covered on the silicon dioxide. This layer of conductor is the MOS tube and gate level. When the gate voltage exceeds the threshold, a conductive channel will be formed between the south level and the drain level. In this way, the south and drain are conducting. On the contrary, south and drain are disconnected. The distance between south and drain is called channel length. This is a very important parameter of MOS tube. Why do I say that? Like the Kirin 9905G chip introduced in Hallweiss press conference. It is the first 7 nanometers plus EUV 5G SoC. The 7 nanometers means that the minimum channel length of the MOS tube in the Kirin 9905G chip is 7 nanometers. After talking about MOS tubes, we are talking about a way to realize resistance in an integrated circuit. First, create an N-type area on the P-type silicon substrate, and then use metal to lead out the two ends of the N-type area. In this way, N1, N2 is the two ends of the resistor. So far, we have learned how to implement MOS tubes and resistors in integrated circuits. Then let's take a look at the voltage divider circuit just now. The purple part in the figure is the metal that plays a connecting role. So the integrated circuit of the voltage divider circuit uses metal to connect the MOS tubes and resistors we just talked about on the silicon wafer, according to the connection relationship of the circuit. Now we can draw inferences from one example. Although the voltage divider circuit is a simple circuit, even if the circuit is more complex, its integrated circuit implementation method is similar. That is, to manufacture various devices required in the circuit on the silicon wafer, and then use metal to connect them, according to the design requirements. Finally, let's take a look at what the chip looks like under a microscope. The picture looks densely packed, all of which are metal traces used for connection. The devices are generally located below the metal layer, and are blocked by metal, so they cannot be seen in the picture. The above is all the content of this issue. Please don't hesitate to contact us.